So our next problem is determine the maximum true power transferred to ZL from source, right? So this is our circuit. So the circuit consists frequency reactive elements like capacitors and inductors also. So that the equivalent circuit is what V Thevenins and Z Thevenins and ZL. Otherwise, we can name it as V Thevenins we can consider as Vs, and Z Thevenins we can consider as Zs, and the load should be ZL, right? But here, just you can observe, this load is varying. So load means is that ZL equals to involves in two parameters. One is RL, and other one is JXL. Here ZL varying means you can consider as RL varying as well as XL also varying. Okay, until unless they are not providing individually, you can consider as both are varying. In case మీకు క్వశ్చన్లో ఆర్ఎల్ వేరీ అవుతుంది అని అంటే మీరు ఆర్ఎల్ మాత్రమే తీసుకోండి, లేదు ఎక్సెల్ వేరీ అవుతుందంటే ఎక్సెల్ మాత్రమే తీసుకోండి. అలా కాకుండా ఇలా యూజ్ చేశాడు అనుకోండి సింబల్, రెండు కూడా వేరీ అవుతున్నాయి అనే విధంగా కన్సిడర్ చేయండి. ఓకే, సో ఓకే నౌ సో ఫస్ట్ this end just you can remove this, just you can indicate this a and b terminals here. Okay, for your understanding point of just you can remove this ZL first. Okay, then you can find out a single equivalent Thevenin's network for this particular given network, right? So first you can draw the circuit as it is. So this is your circuit. Now yes, you can remove this load and you can indicate here VThevenins, right? Now you can find out the VThevenins for a given circuit. So how you evaluate this VThevenins? By applying voltage division principle. By voltage division principle. Okay. So across this entire element, we need to evaluate VThevenin, so that VThevenins equals to, so voltage source value, that is 50 of 0 degree multiplied with this entire impedance value, that is 5 plus J5 divided by total impedance. This is 5 plus J5 and this is minus J5, right? Total impedance. These two are cancelled each other. Then you will get VThevenins equals to 50 of 0 degree into 5 plus J5 divided by 5. This 5 cancel each other. Then you will get VThevenins equals to 50 of 0 degree and 1 plus J. Okay. So if you find out this is rectangular form, right? This is your rectangular form. Now you need to convert it into polar form. So what is the polar form? So you can find out the magnitude, that is 1 square plus 1 square and tan inverse imaginary part by real part. So you will get root 2 and this one 45 degrees. Okay, now you will get VThevenins equals to, just here we have a 0 phase difference, you can ignore this one, right? And 50 root 2 of 45 degrees. Okay, so this is your VThevenins, 50 root 2 of 45 degrees volts. Okay, next you need to find out RThevenins. How do you find out RThevenins? Just you can make it as short circuit. Okay, this entire thing you can make it as short circuited. Then this minus J5 ohm and this 5 plus J5 ohm both are in parallel. So minus J5 ohm in parallel with 5 plus J5 ohm, which is equals to RThevenins. This VThevenins we should consider as Vs. This RThevenins we should consider as ZThevenins, not RThevenins. Z thevenins, we can call it as ZS also, right? So what you will get Z thevenins, so that is minus J5 into 5 plus J5 by minus J5 plus 5 plus J5. These two are cancelled each other, and this you will get minus J into 5 plus J5. So this 5 and this 5 cancelled each other. Then you will get minus J into J minus J square, so that you will get 5 minus J5. Otherwise, you can consider 5 into 1 minus J. Okay, this is your otherwise I will take next page. So this is what Z thevenins equals to 5 into 1 minus J ohms. So if you write it into polar form, you will get 5 root 2 angle of tan inverse imaginary part by real part. I hope this one become 135 degrees. Just once you check this tan inverse of minus 1 by 1. Okay. So now you will redraw the circuit. So this is your Vs and this one is your Rs. Sorry, Zs. And again you should connect your load here. That is ZL. And this is Zs and Z thevenins, which is equals to 5 into 1 minus J ohm, and this is V thevenins, which is equals to Vs, which is equals to 50 root 2 of 45 degrees volts. Okay, so these are the values. Now you need to evaluate ZL value, right? So according to our maximum power transfer theorem, here both RL and XL, wait a second, both RL comma XL are variable, so that ZL equals to what? ZS conjugate, right? Here ZS conjugate is nothing but Z thevenins conjugate. What is the Z thevenins value? So here Z thevenins equals to ZS equals to how much? So that is 5 plus, so 5 minus 5j. This is your 5 into 1 minus j means 5 minus 5j. So for this conjugate means how much? ZL equals to 5 plus 5j. This is your load. Okay. Once you get the load value, then you can find the power. First, before going to that, you need to evaluate I value in this particular circuit. Right. So what is the I value? So that I equals to Vs square 50 root 2. Sorry, I is equal to Vs by total impedance. So that is 45 degrees divided by, so total resistance, total impedance 5 minus 5j plus 5 plus 5j. So these two are cancelled each other. Then you will get 50 root 2 of 45 degrees by 10. So this 10 into 5 is, so I is equal to what you will get 5 root 2 of 45 degrees amperes. Okay, units are very very important. And next, power P maximum equals to mod I square into RL. Okay, mod I square into RL loss. This formula is very very important. So RL, okay, just you can substitute RL value only. Okay, so here I square equals to how much? 5 root 2. Don't take phase value while taking power calculations. So 5 root 2 whole square, and where RL equals to how much? In this ZL, okay, this is RL plus J times of XL. So where RL equals to how much? 5 only, right? Only you can take this 5 value, okay? So into 5. So 25 into 2 into 5. So how much you will get? 25 2s are 50. So 250 watts. So this is the power dissipation to this particular load. Okay, and we have two more problems. So you can solve in, wait a second. Okay, so this is one problem for you, and you can solve in assignment 2, right? And this is also one more problem, same as previous method only. So this just wherever AB terminal is there, at that place you can apply Theorems concept. Then entire circuit should be converted to Theorems and Theorems model. Otherwise, we can call it as Vs and Zs. And then you can compare with maximum power transfer theorem, like ZL equals to Z Theorems conjugate, otherwise Z is conjugate. Like that, you can apply the MPT. So these two problems are homework for you from maximum power transfer theorem, right? Okay. So I think all the problems and all the theorems are completed with this class. Okay. And in the next session, I will start two-port networks. 2 hours content is there. So after completion, so rest of the videos are already available in the YouTube channel. But the first 2 hours content is missing. So I will complete the 2 hours content within 1 or 2 days. Okay. After that, I will post rest of the videos also in your LMS, right? Okay. Thank you.